Hello everyone, hope all of you are doing well. Today we are going to discuss previous question paper and its solutions of CBSE Board Exam 2020. Now we can move to the first question. The question is, two identical resistors, each of resistance 15 ohm, are connected in series and then in parallel in turn to a battery of 6 volt. Calculate the ratio of power consumed in the combination of resistors in each case. Here the voltage in the circuit and resistance are given and we have to calculate the power consumed in the combination of resistors in each cases. Now we have the voltage in the circuit as 6 volt and resistance R1 R2, that is 15 ohm. In the first case, we have to connect both the resistances in series. In series, the connection should be end to end. And we have the resistances as 15 ohm and the voltage is 6 volt. So that we can draw the circuit as shown in the diagram. And then what will be the effective resistance? In the case of series connection, the effective resistance will be Rs is equal to R1 plus R2. So here we will get Rs as 15 ohm plus 15 ohm, that is 30 ohm. And then we have to calculate the power consumed by the circuit. So how we can calculate the power consumed? We have power P is equal to V square by R. Here we can substitute the values of V and R. Then P will be equal to 6 volt the whole square divided by 30 ohm. So that will be 1.2 watts. Now we can move to the second question. We have to connect the resistors in parallel. In the case of parallel connection, we have to connect both the ends of the resistors together as shown in the diagram. And that end we have to connect to the battery that is having 6 volt. Then what will be the effective resistance? In the case of parallel combination, we have 1 by Rp is equal to 1 by R1 plus 1 by R2, right? Then we can substitute the values, that is 1 by 15 plus 1 by 15, that will be equal to 1 by 30 ohm. And again here also we have to calculate the power consumed by the circuit. So we can apply the equation, that is P will be equal to V square by R. So that we can substitute the values of V square and Rp. Then we will get 6 volt divided by 30 ohm. So that will be equal to 1.2 watt again. Right. Now we can write down the ratio of the powers, that is PS is to PP, that will be equal to 1.2 watts is to 1.2, that will be equal to 1 is to 1. So the ratio of power consumption is 1 is to 1. Now we can move to the next question. The question is, draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a combination of 3 resistors of 10 ohm, 20 ohm and 30 ohm connected in parallel, a plug key and an ammeter all connected in series. And we have to find the values of current through each resistor, total current in the circuit, total effective resistance of the circuit. So here first of all we have to draw the circuit, then we have to calculate the current, then total through each resistors and total current in the circuit and the total effective resistance of the circuit. First of all, we can draw the circuit diagram. So it is given that the 3 resistors are connected in parallel. So whenever we are connecting in parallel, we know that the 3 ends of the resistors should be connected together. In both sides, we will connect like that. And from the resistors, we have to connect the ammeter and key, also the cell in series with that. Here we can see that R1, R2 and R3 are connected in parallel and the ammeter is connected to one end of the resistors, that is in series. And then from the ammeter we have connected a key that is also in series, and then we have to connect to the cell, and from the negative of the cell we are connecting to the other end of the resistor. Now we can write down the given quantities. Here we have 3 cells of 2 volt. So what will be the total voltage? So that will be 2 volt plus 2 volt plus 2 volt, that is 6 volt. And the resistances are given as R1 is equal to 10 ohm, R2 20 ohm and R3 30 ohm. And suppose we are taking I as the total current flowing in the circuit and capital R be the total effective resistance of the circuit. Then we can apply Ohm's law here, that is V equal to I into R. Now we can answer the first question. In the first question we have to calculate current through each resistors. So that we have I is equal to V by R. Now we can substitute the values of V and R. Then I1 will be equal to 6 volt divided by 10 ohm, that is 0.6 ampere. Then I2 will be equal to 6 volt divided by 20 ohm, that is 0.3 ampere. And I3 is equal to 6 volt divided by 30 ohm, that is equal to 0.2 ampere. We have calculated the resistance through each resistors. By using that, we can calculate the total current flowing in the circuit, right? That is the second question. So how we can calculate I is equal to I1 plus I2 plus I3. So that we can substitute the values of I1, I2 and I3. Then we will get the total current. I is equal to 0.6 ampere plus 0.3 ampere plus 0.2 ampere. That will be equal to 1.1 amperes. Now we have to answer the last question. That means the total effective resistance of the circuit. From Ohm's law we have R is equal to V by I. Then we have V as 6 volt and total current I is equal to 1.1 amperes. Then substitute the values of V and I. We will get R is equal to 6 volt divided by 1.1 amperes, that is 5.45 ohm. Now we can move to the next question. That is, the resistance of a resistor is reduced to half of its initial value. In doing so, if other parameters of the circuit remains unchanged, the heating effects in the resistor will become A 2 times, B half, C 1/4, D 4 times. Here we have to apply the heating effects of electric current. That is, according to Joule's law of heating, H is equal to I square RT. If other parameters remains constant, the amount of heat produced, that is H, is proportional to R. Here the resistance is reduced to half of its initial value. Therefore the answer is half. Now we can conclude the video. If you like my videos, please like, share and subscribe. Thanks for watching.